So let's evaluate what we know about graphs now. So the first thing I want to do is I want to look at what my zeros are. So you guys should know what all your zeros are. So if I put this on a graph, you guys know that you're going to have a 0 at 0, positive 1, negative 2, and actually you're going to have 2 at negative 2, and positive 4. So let's look at that on a graph. So if we have 1, 2, 3, 4. Okay, so I'm going to have a 0 at 0, positive 1, negative 2, and positive 4. Okay, also, now we need to go through and add up all of our degrees. So if we, if this is to the, if this is to the first degree, this is to the first degree, this is the second degree, and this is to the first degree, we go through and just add them all up. So that's going to be 5. So this is going to be degree 5. Okay, so we're a 5th degree equation. We're going to have turning points. So remember our turns is going to equal 4. And a 5th degree equation, if you recall the video that we talked about this, a 5th degree equation, it's a positive 5th, right? If you look here, it doesn't start off with anything negative, so it's positive. So the beginning and end behavior is going to go off like this and down like this. So what I do, like I said in that video, is I draw my arrows first. So I'm going to go over to my graph and I'm going to go ahead and draw those. I'm going to draw an arrow down here and I'm going to draw an arrow up here. Okay? So I know that's my beginning and end behavior, and I know what all my zeros are. So now what I need to do is I'm going to decide whether or not I'm going to go through or bounce off. So this is called cutting through or bouncing. If it is an odd power, so if your 0 is an odd power, you're going to go through it. And if it is an even power, you are going to bounce off of it, because basically there's 2 of them there. If there's 2, basically 2 roots at negative 2, you're going to bounce there. Okay, so my first 0 that I'm going to come across from left to right is negative 2. So at negative 2, I'm going to start here. I'm going to go left to right. That's actually where I'm going to bounce. So by bouncing, it means I'm going to go up and touch it and go back down again. At negative, my next 0 is 0. So that's odd. So I'm going to go through it. Positive 1, I'm going to go through it. And positive 4, I'm going to go through it. And I'm going to connect my lines. So what we don't know, and right now it doesn't really matter, I'm not concerned with this right now, it doesn't matter where I make that turn. So don't concern yourself too much with where you make this turn, because I could have just as likely drawn this graph. I definitely had to bounce there, but I could have gone further down and further up and back through and further down. That really doesn't matter. Let me see if I can get rid of that one. Nope. Oh, good, I can. So it really doesn't matter how high or low you go. I just want you to get the concept that at each one of these, you need to know whether or not to bounce through or cut across. So let's do another example. Actually, let me just go. Okay, so let me put another example up here. Let's do P of x equals x minus 3 squared, x plus 4 to the 4th power, x minus 5, something like that. So let's add up all of our degrees. What's my degree? My degree is, so I'm going to have a 1, a 2, a 4, and a 1. So make sure you put those degrees up there. So 6, 7, 8. So my degree is 8. My turns are going to be 7, right? You do 8 minus 1 is 7, okay? So let's put a coordinate system up here. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so what are my zeros? So I have a 0 at 0. I have a 0 at positive 3. I have 1 at negative 4. 1, 2, 3, 4. And I have another one at positive 5. Okay, so if you didn't see those, that was 0, 3, negative 4, and positive 5. Those are my zeros, right? Okay. If it is a even degree, then you know this, and it's a positive parabola, or excuse me, it's a positive polynomial. So you know that thing is going to look more like a parabola, right? You know the beginning and end behaviors, hopefully, are going to look like this. Okay? Because if it's even, it looks similar to a parabola that goes up and up. Okay? So I draw my end behaviors first, and now I go through each 0 from left to right. So at -4, it was an even number. So I'm going to go down and bounce off of that, okay, because it's even. Then my next 0 is 0, actually, so I'm going to go cut through that because it's an odd number. At +3, it is another even number, so I'm going to go back up and just bounce off of that. And at +5, it is an odd number, so I'm going to go up and go off to infinity. So I shouldn't have drawn that. I should have drawn it further to the right. And again, it doesn't matter how high or low these bumps go. I just need you to see that I need you to know whether or not they cut through or bounce off. Okay? So here's a new word for you, multiplicity. So multiplicity just is saying how many times a 0 is being repeated or a factor is repeated. So if I have x plus 3 squared, that means that I have a 0 at -3, right? The 0 is -3 with a multiplicity of 2. So the multiplicity is 2. Usually put a comma there. If I added another factor in here, say I had x plus 4 cubed, that would simply say that -4 is a root, or 0, and it has a multiplicity, I'm just going to abbreviate it, of 3. I've told you before, mathematicians are kind of lazy people, right? So we just don't want to write this stuff many times, because basically what's happening is I've got a root at x plus 3 and another one at x plus 3. So as you know from before, this root is it's going to come down and bounce off, right? So this is going to come down at -3, 1, 2, 3. I don't know which way this is looking. But, I've got a root that's coming down and bouncing off. It's bouncing because it's even, remember. If it's odd, it cuts through. And it just means that there's 2 roots there. I just don't want to write it out twice, so that's why we do it squared. Okay, so -3 has a multiplicity of 2. When you are looking at graphs, this is going to become key because as you're trying to narrow down, let's say, a 5th degree equation, and you're trying to squeeze that down and you can see that there's a root, so for example, we know that this is a 5th degree equation, right? So, actually, let's go ahead and look at this. This might be interesting to look at. So we know that we have 1, 2, 3, 4. This is a 5th degree equation, so we know that this, and it's a positive 5th degree, so we know it's going off this way and up this way. At -3, it's going to bounce. So at -3, it's going to bounce, and at -4, it's going to cut through. So this is going to cut through, it's going to bounce off, and then go back out, right? So that's basically what this graph looks like. But when you're looking at your graphing calculator, you're looking for those 5 roots, and later we're going to eliminate, make sure that there aren't any imaginary roots kind of hiding in there, because remember, imaginary roots don't appear on our graphing calculator, so to speak. So you have to have a little bit of knowledge and know, okay, well, if it's cutting through, I know that's going to be some even number, but I know if it bounces off, that's an odd number. Or excuse me, I'm sorry, if it's cutting through, it's an odd number, and if it's bouncing off, it's an even number. So we know that as soon as we look at this graph, and I can clearly see from the graph that -3 is a root, I can assume that there's another -3 root going on there. There's 2 roots going on at that -3. So that reduces my equation down from a 5th degree equation. I can do my synthetic division by -3 and then do synthetic division a second time by -3 and get down to a nice trinomial, which will be easier to deal with. Okay?